Hey guys, today we are going to be taking a look at 7.3, which we're going to be learning about rational exponents and radical expressions. And so before we get started looking at these two things, we want to know what they are. So a rational exponent is a fractional exponent, which can be written as a radical expression. So for example, what I mean by a fractional exponent is that if I have x to the 3/4, the actual exponent here is a fraction. So this is called a rational exponent. And then rational exponents can be written as radical expressions, which include a square, cube, fourth, root. And so these are things that look like this. So if I have the square root of x, this is a radical expression. You could also have the cubed root of something. So these are both radical expressions. And rational exponents and radical expressions, they're essentially the same thing, and we can go back and forth between these two ways of writing or expressing things. And so that's what we're going to learn how to do right now. But before we dive in, there's a little bit of vocab that we need to touch on. So when we are looking at a radical expression, we need to know what these different parts are. So this little number that goes right here, and it can vary. If there's no number there, then you assume that it's just a 2. It's a square root. But it could be a 3, 4, 5. This is called the index. This is the index. And it tells you what kind of root you are taking. And when we're actually simplifying these, it tells you you're going to be taking groups of n, and that'll make a little bit more sense when we get into simplifying, but it tells you what kind of groups you're going to be making. So that number is really important, and it is a small number, so you can't forget to add it on or pay attention to it. Within the radical symbol, that's what this is here, it's just a radical symbol, we have the radicand, which is what is under the radical symbol. So this is called the radicand. And then finally, we also have, you could possibly have an exponent as well. So the way that we would write this expression as a rational exponent is that we would have b to the m over n. So you would have the exponent on top being divided by whatever the root is. And we see over here the same kind of thing, but it's just set up a little bit differently. This would also be b to the m over n. But in this case, everything that is under the radical is being raised to this power using the power rule that we've already learned about. So you could have multiple things under the radical, and in this case, they're all being raised to this exponent.